I come because I like to learn about what is going on in the industry. I like to hear from the contractors, especially because being an engineer, sometimes it's good to learn from the contractors what innovations they're coming up with, and obviously to meet with other folks and see what they're working on.
This conference is probably the most important event during the calendar year, so you cannot miss it. Because here you can meet a lot of people, contractor, supplier, competitors. So as I said, it's the most important event in the calendar for foundation business, and it's too important to don't be here, let's say.
We come because we get a lot of exposure to people who use our equipment. Camaraderie, a lot of camaraderie. Even with our competitors, we come out and we rub shoulders. Everybody knows everybody. It's just one big happy family.
Well, it depends on whether or not you want to continue learning. If you got a desire to continue to learn, then you need to be at DFI.
The good thing about this conference, you can meet a lot of people over and over, so you can make a very good connection with the industrial people.
Networking's huge. There's so many people here, just from different parts of the country and the state and the world even, and just seeing what processes they're using and their design methods and their equipment, and just really a lot of exposure, and also getting connected with those people for potentially future work, future jobs.
Come join us if you're interested in anything in this industry. This is the place to be. This is it.
I'm Jonna. I work in the geotechnical field. My job's interesting, exciting. Wait, what? You don't know what the geotechnical field's about? No problem. I have some friends who can help with that.
Hi, I'm Lori Simpson. I'm with Langen Engineering, and I'm on a job site in Oakland, California, where they're going to build a 400-foot tall high-rise. So these are the piles that are going to support that high-rise. It's going to have a basement, so we have a whole lot of shoring in to make this excavation. They're chipping down the piles now to subgrade, and we're out here to watch the piles, we watch the shoring go in, and we're checking the subgrade to make sure that the subgrade is good for a mat foundation that's going to get poured on these piles.
I'm Jules, and I'm managing a crew building a 239-foot diameter unreinforced diaphragm wall shaft.
Hi, my name is Fanny. I'm an assistant project manager with Thatch Foundation. We are currently installing sheet piles for a brace excavation of 14 feet deep.
Hi, I'm Natalia. I work for Tincada Mirakai as an engineer business manager in Florida. I'm in the field today to install some high-performing fabric.
I'm Peggy. I'm down here mapping out the structure of the sinkhole so that we can put a building on top of it.
I'm a geostructural engineer. I might have designed the dam that powers your city.
I'm a geotechnical contractor. I may have built the foundation of the building that you're in right now.
We manufacture rock drills so contractors can build mountain roads that won't fail.
I manufacture drilling equipment that is sometimes used to search for buried treasure.
I'm a geotechnical engineer. I drill, dig, and explore what's under the ground. I get really muddy.
I build.
I design.
I educate.
I conduct research.
I'm an integral part of this dynamic team.
I manage major projects.
I calculate. I supply specialty equipment
and materials.
I love what I do.
So, what do you think? Want to know more? I thought you might.
Good afternoon, everyone. Thank you very much for joining us today. DFI India welcomes you to the webinar 3 of Steel Retaining Structures and Foundations. My name is Lucky Nagarajan. I'm also known as Sri Lakshmi Nagarajan. I'm the General Manager of Engineering and Business Development, work out of New York office of Deakin America Corporation. I'm also co-chair of DFI India Support Committee and chair of Women in Deep Foundations. Just wanted to bring few things to your attention. There is recording of this webinar is prohibited. Certificates will be prepared and emailed in approximately 2 weeks. Online webinar recording along with presentation slides will be available approximately in 2 weeks to all the attendees. If you need any assistance during the webinar, please reach out to one of the DFI India staff, P.S. Mahendran, Pranav Jha. Their phone numbers and emails are here. You can reach out to them if you have any problems during the webinar. So just wanted to go through the attendee control panel really quick. So you can see the left side panel where you can see the whole presentation in full screen mode. Also, if you can't hear us, please check your computer audio. If you're using headphones, check your headphones to make sure you can hear us clearly. And also, we want to bring attention to the handouts. There is a tab in the on your right side of your computer, handouts. So you can check the handouts, and these handouts section will have all the information that is shared during the webinar today. And you don't have to take down anything during the webinar. It also has upcoming webinar, DFI, upcoming conference, India conference, and also information on all the emails. So make sure to check that out. You don't have to write down any information during the webinar. And if you have any questions, you can put it in the question and chat, and one of our staff will take a look, and the panelists will take a look and then reply back to you. And throughout the webinar, you can actually add questions in there for the speaker and also for the DFI staff. And we like to thank our webinar series sponsor, ArcelorMittal Project India Private Limited. Thank you, ArcelorMittal. And we also have co-sponsor for the webinar series, Teamwork Engineering Solutions Private Limited. Thank you very much, Teamwork. And I would like to share some other information with you. The sponsorship opportunities for the webinar series are open. Please reach out to DFI India office. You can see the email address right there. And these are the upcoming webinar series. The webinar 4 is on 9th September, 5 is on 23rd September. Webinar 4 will be presented by Mr. Ernst Weber, and webinar 5 will be presented by Mr. Shavo Martins from ArcelorMittal. And webinar 6 is going to be presented by Geek in Singapore. Webinar 7 details will be coming soon. Keep an eye out for it. So we just wanted to bring you how many people are registering and the industries they come from. So this chart actually shows you we have total about 810 registrants so far, and you can see they come from variety of industry sectors. And also, we have a new person from Hong Kong attending today. It's great to see that we have covered 32 countries so far. So this will be the sequence for the webinar 3. So speaker introduction, presentation, and after the presentation, we will have a short promotional video, and then we will have a question and answer session, and then we will give you the details of DFI upcoming 2020 India Virtual Conference. After that, you have an exciting exciting information on Women in Deep Foundation's India Committee, and a few other miscellaneous information, and then we will end the webinar number 3. So, what is the title of the webinar today? HZM, AZ Steel Wall Solutions for Port Construction, Innovative Solutions. Our speaker, Mr. Shao Martins, head of the Technical and Marketing Department, ArcelorMittal Commercial RPS Sheet Piling, Luxembourg. Welcome, Shao Martins. Let's get to know a little bit about Mr. Martins. So Mr. Martins started his professional career in 1996 as an inspection engineer in the consulting firm in Luxembourg. He moved to ArcelorMittal in 1999, where he held several positions in the technical and in the marketing department of the sheet piling department. He started designing sheet piles for customers and worked as a resident engineer in the USA for 3 years, where he was in charge of technical assistance. He had the opportunity to visit many job sites all around the world during this period. He works now in the marketing department, and he's also the link between the R&D and the sales department. His main mission is to develop and promote new and innovative steel sheet pile solutions. Welcome to our webinar 3, Mr. Martins.
Thank you very much. I hope that everybody can hear me. So for this session, I will focus on a combined wall system that we have named HZM-AZ. It's mainly used for port construction, but not only exclusively. So I'll go through some of the applications during the next slides. Okay. So for those who have been present in the first of these webinars, you'll see some of the slides that are quite similar. I mean, the combined wall system, the main applications are, as I said, for waterfront structures, mainly for very deep quay walls, but not exclusively. So if you have high retaining walls and deep cofferdams, especially in the water, then it's also a very good solution. And the third application type that you'll find are structures where you have limited deflections requirements, such as cantilever walls, because the moment of inertia of a combined wall system is much higher than of a standard regular Z or U-type pile. For the marine structures, normally you have a typical quay wall with a head wall, an anchor, or 2 levels of anchors, and anchor wall. So most of the time, this type of structures are effective for retaining walls between 10 and 20 meters of dredge level. Of course, it will depend on the soil. Of course, it will depend on the loads and on many different parameters, such as the water, tides, and so on. But typically, the range goes from 10 meters of dredge level up to 20 and more, depending on the soil conditions. And for flood protection systems, here it's a typical case where a standard sheet pile wall would have been possible, but in this case it's a cantilever wall, and so in order to reduce the deformations at the top of the sheet pile, it was decided to use a combined wall system due to its much higher inertia. So relatively small retaining height, but due to deflections, they used this type of solution. And as you can see, this is the second part of the presentation. The installation is made in a different way than regular sheet piles, so you need a template to install the sheet piles, and there is a specific driving sequence that you have to follow in order to do it correctly. Now, another type of applications are bridge abutments. Normally, again, regular Z piles could be used, but in this case, very high loads, and you transmit also the loads from the deck to the sheet pile so that they can be transferred to the soil. So it's not only a retaining wall, but also a bearing pile, acting also as a bearing pile. And now, temporary structures with this type of combined wall systems are not used that often, but in very severe conditions, like you see it on the right, it's a very old picture of a cofferdam in the middle of the water where they had over 10 meters of water pressure. So they decided to use a combined wall system. And on the left, also, you can see this excavation. We're going to use the pointer. Where you also see this combined wall system, which we call combination 23. So it's only those king piles without infill sheets, but this is also to limit the deflection of the structure. So next slide. I'm sorry. Case studies where sheet piles have been used. Well, this is one in India. It's the new dry dock for the Cochin shipyard, the depth of 13 meters. It's 310 meters times 60, respectively 75 meters of width. And for this one, we supplied about 11,000 tons of this combined wall system. But the sheet piles are very, very long. So here, the longest were up to 44-meter long. So you have also to imagine the equipment that you need to be able to drive such a long sheet pile into the soil. So this is also something that will be dealt in one of the next webinars, so webinar with Mr. Ernst, who will focus on the installation. I will just go very quickly over the installation, which is specific to combined wall system. So as you see here on the right, again, you need a specific template to drive the sheet piles, the king piles, so that they are positioned correctly, and then you can come with the infill sheets. Having some trouble with the slides. This is a very interesting project which was built in 2018, 2019. So we supplied the sheet piles into, sorry, it was too fast. It was a project in Denmark where we supplied the sheet piles, and the interesting stuff about this one is that the anchor level is 3 to 4 meters below the water level. So this is more difficult to install, but as you see, there is a specific system where you don't need any welding to the sheet piles in order to install these anchors. So it's a tie rod. But by using this system, you can reduce the maximum bending moment so that you can reduce not only the length of the sheet piles, but also the section modulus that is required. And if you can install the sheet pile, the anchors below water, then it will definitely be a good solution. So you will reduce the amount of steel which you'll need. Now, of course, you need some divers to do this installation. It's a little bit more difficult. It takes a little bit more time, but this is something that's still regularly done in Denmark and in other Nordic countries. Another interesting feature of the HZM system is when you have to dredge deeper. Here, for instance, they wanted to increase the dredge level by about 3 meters. Okay. By about 3 meters. It's a deck on pile. I'm sorry. I'm having trouble with the. So here you can see it now normally. So you see the deck on pile, and they wanted to increase the depth by about 3 meters. So the installation, the solution was to select a cantilever wall, but which is relatively stiff. So it was an HZ system, which was driven, as you can see, below water. So the top of the sheet pile was at the existing dredge level. And then once they had installed the sheet pile, they dredged in front of the sheet pile so that it was a cantilever wall. Now, what are the standards and recommendations that should be used when you are designing a sheet pile wall? So in Europe, we use Eurocode 3, Part 5 for the piling, for the steel. Eurocode 7, that's for the geotechnical design. That's Part 1 of Eurocode 7. And then there are some recommendations that can be used. There are also standards that are relevant for the sheet piling, hot rolled steel sheet piling, the technical delivery conditions and the tolerances. So this is very important. The execution of special geotechnical work is detailed in EN 12063, but we'll see for combined wall systems, for instance, the tolerances are not dealt in detail in this standard. And then the types of inspection documents that you have to prescribe so that you get the correct material. And then there are recommendations, which are the recommendations of the Committee for Waterfront Structures, Harbor and Waterways, the EAU that we call in Germany. Very interesting, very detailed, and they use a lot steel sheet piles in Germany, so they have a lot of experience. This is the 8th edition, if I'm correct, so they improved it each time. And what they have also is a EAB that's more for cofferdams. So if you're doing something on land, then it would be EAB. And then in the Netherlands, but this is only available in Dutch, but also very detailed for the design of sheet piling, it's the Cure 166. Now they have renamed it. It's also a standard, but nevertheless, it has a lot of details, not only how to design, but also how to install sheet pile. So this is quite interesting. But of course, if you are doing a design in your country, you have also to follow the regulations and the laws from your country. So focusing on the combined wall system, HZM, what is a combined wall system and what is particular about this specific one? The combined wall system consists of 3 elements. The first one is what we call a king pile. This can be an HZM, like in this case, but it could be something else. It could be a box pile, like a CAZ box pile. It could be a tube. And then you have infill sheet piles. In this case, we use exclusively AZ sheet piles. We will see also why AZ sheet piles are better in most of the cases. And then to connect these 2 elements, sorry, the third element is the connector. It's also a hot rolled connector, and it's partially welded to the king pile. So this is the way how to combine these different elements and how to build continuous and could also be watertight sheet pile wall, as we'll see in one of the slides. So king pile and an infill sheet. If we focus on the king pile, the system is not that new. So the first HZ was developed in the 70s, early in the 70s. But as you can see here on the top, the infill sheet piles were specific for this system. And then later, with the development of the AZ sheet pile, we switched to a regular infill sheet. So it's something that can be used not only for the combined wall system, but also for a standard retaining wall. And then later in 2007, for a very specific project, we developed much more resistant, so thicker piles, so king piles, but keeping also the infill sheets, still the AZ and the same connectors. So it's an evolution, like in most of the cases. What changed and what is very different for this king pile compared to a section, for instance, is that it's much wider. We're talking here about sections which are between 420 for the smallest one up to 460 millimeter wide. They're very deep, above 1 meter high for the highest one, so like jumbos that are also used for high-rise buildings. And also the distinctive feature, which is different from the other solutions, is that we have here a groove which is milled, and we can actually be within very strict tolerances so that the connector will fit perfectly in this type of flange. There are different elements, so different thicknesses, different heights. We start with a very small one, which we called the 630. Then you have one which is a little bit higher, 880. And then the largest one are the 1080 and the 1180M. As you can see, the thickness of the flanges also increases. We have a specific slide about the thicknesses in one of the next slides. The connectors, there are 2 of them, actually 3 of them. Those to connect the sheet piles, the infill sheets to the king piles. We call them RZ, RZD and RZU. It's almost the same shape, but due to the interlock type, you have to select the correct one. And then the RH connectors are used to connect 2 king piles together, either to build a box pile, like we'll see, or to build a wall without any infill sheets, which is a much stiffer one. So the connectors are hot rolled connectors. They're also partially welded to the king pile, around 10% of the length. And then there are 2 sizes that are required because of the varying thickness of the flanges in order to fit perfectly the flanges thicknesses. So in our brochure, you'll see different solutions and different combinations. So what we call a solution is simply the king pile. And as you'll see, a solution 12, for instance, is 1 king pile with 2 connectors. Solution 14 that you see here is a solution where you have 1 king pile and 4 connectors. The advantage of a solution 14 is that it's almost a symmetrical profile. However, the disadvantage is that the connectors are a little bit more expensive and that you also need to weld them, so that most of the time a solution 12 will be more cost effective than a solution 14, but you have to switch also the king pile, so you have to take a larger king pile. And it's the same thing for the box piles that we call 24 and solution 26. So solution 26, 2 king piles connected with these RH connectors and 4 other connectors. A combination is the combination of a solution, so solution 12 plus infill sheet, that makes combination 12. The same thing with a solution 14 makes combination 14, and so on and so on. So relatively easy to understand. Also in our catalog, where to find these different types and what it makes. Now there is a combination C1 and combination C23, and in this case you have no infill sheets. Those are very stiff solutions with a very high suction modulus, but of course they are also much heavier. So combination C1 means that you have 1 king pile that will be driven as a single pile, and combination 23 you have a box pile that is supplied as a box pile, so 2 or even more. We have also supplied sometimes 3 HZ as a box pile, but then also you have to handle it and to lift it and to drive it into the ground. So that's something that has to be taken into account also when ordering them and designing them. So as I said, there are 4 different sections with different thicknesses. I won't go into the detail, but we start at a thickness of about 20 millimeters for the very small one, and we go up to about 40 millimeters for the very thick one, with the height of the section of 1100 millimeters approximately. So there are different thicknesses for each, so that you can actually optimize the solution depending on your requirements. And as I said, depending on your requirements, you can have a very small elastic section modulus. So here we have, for instance, a combination with the 4,000 cubic centimeters per meter. This is the equivalent to an AZ40, for instance, but the inertia is much higher. So the inertia here would be about 50% to 100% higher than an equivalent Z pile. And if you don't use any infill sheets, as a combination C23, we can go up to 46,000 cubic centimeters per meter for the elastic section modulus. But on the other side, the weight that you have to consider is about 1 ton per square meter. So if you take one of those box piles that is 40 meters long, this means that it's about 40 tons heavy. So you need the equipment to handle it, but also to drive it into the ground. Now we have developed such a milling equipment, well, here you see the concept, in order to guarantee a tolerance of less than 1 millimeter. And this was done in less than a year for this very specific project in Germany that we had to supply, and that was in 2008. Also a picture of the equipment. It looks very easy, and it's not that complex once you have chosen the right methodology and also the right equipment. So for instance, it takes about 30 minutes to mill 30-meter long pile. So it's relatively quick and, as we said at the beginning, very small tolerances. Now, the HZM system, as I said, consists of two elements, but the infill sheet is there mostly to transmit the horizontal loads to the king piles. So the vertical loads, if you have vertical loads from a bridge abutment, for instance, will be transmitted solely to the king piles. And the other advantage of the AZ sheet piles is that they adapt very well to driving tolerances. The other advantage of a combined wall system, HZM, with the RH connectors is that you have a mechanical connection. So you partially weld the connectors to the HZ, but even if it would break for some reasons, you would still have a continuous wall, which is not the case for other solutions, also with the king pile walls and infill sheets. So how to design and how to determine the stresses in both elements. So it's relatively simple, but you have to do some assumptions. So the easiest way to explain to you is to take the global safety factor approach, in which we don't have any partial safety factor and so on. So we have to make an assumption, and the assumption is that the bending moment of the wall will be transmitted to the elements proportionally to their stiffness. So the king pile is much stiffer, so that the bending moment will be transmitted mostly to the king pile, and the infill sheet, as I said, will transmit the horizontal loads and can take a small portion of the loads of the bending moments. So the inertia of the system, you simply add the inertia of the king pile and the inertia of the AZ, and you'll find this information also in the brochure, so more in details. And you assume that the bending moment is also distributed into the HZM and the infill sheets. Now, you have to calculate the bending moment that is transmitted to the HZM, and once you have calculated that, you can calculate, you have to verify the stresses in the HZM and also in the connectors. And those are the formulas that you see here. So it's relatively simple. And in our brochure, you'll find what we call equivalent section modulus. So two values, one for the HZ and one for the connectors, because they don't necessarily have the same stresses, and they don't necessarily have the same yield strengths. And this is how you can calculate the stresses in those two elements. And for the infill sheets, it's the same. So you take the inertia of the infill sheet and you divide by the inertia of the system. And in this table, you'll see that, for instance, for a very big king pile and the lightest infill sheet, which is the AZ13700 or the 770, you see that the inertia of the infill sheet is about 1%. So almost all the bending moment goes into the king pile. Whereas if you take a smaller king pile like the 880 MA and a larger infill sheet, in that case, you might have 20% of the inertia ratio, so that a little bit more of the bending moment will be taken by the infill sheet. In this case, it would be around 40%. But this is also something that you can calculate with the software. What you can also deduce from these assumptions and from these results is that usually the infill sheet pile doesn't need to have a very high yield strength. So generally an S270 GP would be sufficient, unless you need it for driving reasons, if you're driving into very compact soils, or for water pressure reasons, as you'll see in one of the other slides. So all this information you can find in our brochure. You can also find in the brochure of other manufacturers, because this is the essential data that you need in order to design a sheet pile wall. You've also seen this slide in the first webinar. However, I grayed out all those low yield strengths because, as I said, if you use steel that's produced in an electric arc furnace, nowadays S355 GP is the minimum that you can achieve. So there is no difference in pricing normally if you use a 240 or 355. This is different for sections. We are talking about sheet pile. We're not talking about other products. And then we need to add some alloys in order to achieve the S390, as you can see here, or S430, or even the S460, which is not standardized yet, but will be in the next version of EN10248. We can also supply according to ASTM, and then you have similar steel grades, grade 50, grade 55, and 60, and so on. The yield strength is a little bit different, but this is something that you can also adapt. We have also supplied for some of the projects ASTM A69. That was the case, for instance, for a large project in Poland about 10 years ago. And we can also add some copper if the customer requires it. Usually it's a little bit more resistant to corrosion in a marine environment. So as I said, all these verifications according to the global safety factor approach, not the Eurocode, can be done with the software that you can download from our website. You have also the possibility to do a very simple material list where you'll see that you can choose different lengths, so the king piles and the infill sheets and the connectors. The infill sheets are normally shorter, as you will see why. But also, if you don't find the information, the data about the section models in our brochure, you have a database here with any infill sheet pile that you can find in our catalog, so that you can actually do what we call tailor-made solutions. Now, if you do it according to Eurocode, it's a little bit more complex, because in Eurocode you have classification, just like in the United States. If you use LRFD, you have a compact section, semi-compact, and so on. We call it in Europe class 1, class 2, class 3, and class 4. So class 4 are sections that don't achieve the elastic section modulus or elastic bending moment capacity. And this is relatively easy to determine for sections, because there was a lot of research done. But for curved flanges like we have here, or sheet or flanges which are not straight, but with a connector, it does not necessarily apply. So what we had to do some years ago is to do some research and also testing in the laboratory. It was done with the University of Aachen in Germany. And these finite elements and background calculations showed that almost all the solutions were class 2, except for one, which is the solution, solution 12 and solution 24, which are class 3. So this means that for all of them, you can use at least the elastic section modulus for all the steel grades. Quite interesting, because it was not that easy. And if you use the method from the sections, then in that case, we would have some in class 4. So another interesting thing is that the infill sheet pile does not need to have the same length as the king pile. We can actually take into account a passive 3D effect, but this depends on the distance between the king piles. So if the king piles are within 1500 millimeters or 1.8 meters for U piles, then you can assume that it's a continuous wall. If the distance between the king piles is above this value, and this is also given in Eurocode, then you have to take into account, you cannot necessarily do it without any verification. You still can do verifications and make sure that it's you have this passive 3D effective, but it's not given without any additional verification. So of course, with this type of solution, you can save some money, so also some steel, which is also good for the environment. And typically, the length of the infill sheet piles are within 60 to 80% of the length, unless you have a cantilever wall or a very soft soil. Now here, it's a cross section of a cantilever, of an anchored wall. You see that the RH connectors, for instance, you only put them where you need this maximum bending moment. So you can also not only play with the length of the infill sheets, but if you have a combination 24 or 26 or 14, you can also adapt the length of the infill of the connectors. Normally, the tip of the sheet pile, of the infill sheet pile, should be at least 2 meters below the elevation where you have the 0 earth pressure level, so where the active and the passive are equal, and then you have 2 meters, but also it should be at least 5 meters of embedment, depending on the soil conditions. Good. What else? Already told you that the solution 12 would normally be cheaper than the solution 14, but you have also to verify that the stiffness is sufficient, and a solution, well, 24 is cheaper than a solution 26 and 12 and 14, but as I said, you can also optimize the length of the connectors based on the bending moment. For the infill sheets, why do we prefer Z-piles? Well, for two reasons. The first one is that you have a Z pile which has a rotational capacity of about 5 degrees per interlock, which is not that much. But without any deformation, you can actually achieve an increase or decrease in the width of, let's say, 100 millimeters for most of the piles. And with a small deformation, you can adjust it to about 200 millimeters. So based on our experience, we can say that due to this 3 pivot point, the Z pile is better than the U pile because it doesn't have the interlocks on the neutral axis. And if you are within 200 millimeters of installation tolerances, the infill sheet will adapt to these installation tolerances. Because, of course, when you drive the king piles first, you will never be able to have a sheet pile or king pile which is perfectly vertical. There are some tolerances, but it will be very difficult to achieve zero, almost impossible. And then that's the advantage of the infill sheet, which is a Z pile. However, as you've seen, most of the time, the infill sheet piles are crimped at the top. So you have 3 times 3 crimping points. This is more for handling the double piles so that you can lift them and so on. So you should avoid crimping at the tip because you need this flexibility, as I said, in order to adapt to the installation tolerances of the Z piles. Now, we've seen that the yield stress of the king pile might be different from the yield stress of the infill sheet and from the connectors. So this is something where you can try to optimize because, as I said, if you go to a very high strength, you have to pay a slight premium, but for the infill sheet piles, you don't necessarily need this. The tip of the pile, you can also shorten it. So we've seen that it has to be at least 2 meters below the total zero pressure, and the embedment of the HZ must at least be 5 meters. And we also recommend that the AZ should be at least 5 meters, but most of the time it's the case. And if you have very long piles, like longer than 20 meters, in that case, we would recommend to use a slightly stiffer pile, not too stiff. So AZ48 700 not recommended at all. It would be too stiff, but an AZ13 might not be sufficient in order to drive them. But of course, it depends a lot on the soil conditions and the installation equipment that you have. For water tightness, we have also some solutions. So this is typically not for a cofferdam. This is typically for a cofferdam, not for waterfront structure. So you can use what we call Belton Plus. So it's a bituminous product that you put into the interlocks, and then you seal weld here in between the structural welds. Or you have also a system which is a compressive system where you use the Aquila system in the interlocks, but you have also to seal weld in between. So we have done some simulations and testing also in the laboratory in order to make sure that they can resist to a lot of water pressure. And the result is that if you have water pressure in this configuration, so which is a typical one, we can also turn it upside down and then it will resist to a high water pressure, but in this case it's a typical situation. We can resist to about 14 meters with our sheet piles and the HZ without any declutching. But this is only valid for our system because you might have failure in the HZ or in the AZ if it's very sensitive to the tolerances, but also the shape and the interlock. So 14 meters of water pressure is already a lot, but sometimes you have to go higher. For the delivery conditions, it's the same as we've seen in the first webinar, so plus and minus 5% of the mass, and so on and so on. Straightness, length, this is regulated in EN 10 to 48. 48 also plus minus 7 millimeters, and plus minus 7 for the HZ and so on. So this is relatively standard. And then for the rolling lengths, we have also seen that AZ can be rolled up to 31 meters. If you need longer lengths, then we have to splice them. And for the HZM, it comes from another mill in Luxembourg. It's 33 meters. If you have to splice it, again, it's feasible, but it has an additional cost. So very often we had the case where they wanted to have a 33.5 or 34 meters. Then you have to check if it's not better to position the anchor a little bit deeper or reduce the length of the sheet pile at the top so that you can make it with 33 meters rather than paying for the splicing. But of course, if you have 44-meter long piles, then you don't have any other choice than to splice it. There are also some forms for the delivery. The difference is where we weld the connector. In this case, we weld the connector only to one of the piles, but the form B is the standard form where we weld the connector to both of the piles. So unless there is a good reason, we will supply form B. And as I said, there's 10%. So every meter you have 10 centimeters of welding, which is 6 millimeters thick. And then at the top and at the tip, you have 500 millimeters. However, in Germany, they are a little bit more strict. So at the tip and at the top, they want at least 3 meters and 20% over the length. So it is feasible, but it has an additional cost. If you have a very hard driving conditions, then it makes sense. If it's regular driving conditions, then this is more than sufficient. And if you have to seal weld, as you see it here, then you can seal weld it in between this structural weld. So instead of 6 millimeters, you'll have only 4 millimeters thickness. Durability doesn't change anything. It's steel, so it corrodes. In undisturbed natural soil, not that much. You can even neglect it. But in seawater, you have to take that into account. Mostly in the splash zone and also in the low water zone. That's the most aggressive zones that you have. Luckily, the permanent immersion zone where you have less corrosion rates is where you have also the bending moments that are maximum, so the maximum stresses in the steel. And by playing with the length of the pile, but also the position of the anchor, you can actually also change the position of the maximum bending moment so that it will not or will never be in one of those very highly corrosive system zones. However, there is a small difference between a combined wall system and a standard sheet pile. Imagine that you have a waterfront structure, so the water is more corrosive than the soil, so you have less surface in contact with water than compared with the standard Z pile. And we did this for specific solution, equivalent solution a couple of years ago. So you see that after 50 years, the solution, the difference in elastic section modulus would be about 6%. Now we did also analyze the influence of the corrosion on the classification, and with a loss of steel thickness up to 8 millimeters, it changed the classification of some of the sections. So you see there are more class 3 sections in this table. However, they all stay in class 3, so we don't have any class 4, which is a good thing because then you can use the elastic section modulus even with a corrosion case. Now we did market analysis in for a typical quay wall for a cruise ship terminal in Belgium with a draft of about 13 meters and a length of 200 meters. We compared the sheet pile wall solution with a deck-on pile and with a diaphragm wall, and we did different solutions for the sheet pile, so regular sheet pile, HZ, and also tubes. And this is interesting because the most for this specific draft and under those conditions, soil conditions, of course, the sheet pile wall turned out to be 15% cheaper than a concrete diaphragm wall. But why did we choose these 13 meters of draft? The reason is very simple. We know that in the Netherlands and Germany and in Belgium, if you have less than 10 meters, then the sheet pile solution is the solution that will be used because it's cheaper. And if you go above 20 meters, then of course the technical solution for a sheet pile is still possible, but a diaphragm wall will probably be as cost effective, if not cheaper. So this is the range between 10 and 15 where a sheet pile wall, combined wall system, and a diaphragm wall are competing, and that's why we wanted to analyze this type of solution. And from a life cycle assessment, which is also very important because in fact we want to reduce the environmental impact, we analyzed an indicator which is a CO2 equivalent, and in this case, under those assumptions, the sheet pile wall is 45% less, has a 45% less environmental impact. But of course, this applies only to this specific project. and under those conditions. And this life cycle assessment is being peer reviewed by an expert group. For the installation, you'll have more details in the next webinar. So you can use diesel hammers, impact hammers, vibratory hammers. Hydraulic presses are not used that much for the HZ system, but they can be used for tubes, for instance, the solution from Geeken. And then you have the accessories, which you call leader, as you can see on the pictures, to make sure that you lead the pile correctly. And then driving assistance like water jetting, pre-drilling, if you are in soils like sandy soils, can be very helpful. If you use an impact hammer, it's very important to distribute the energy correctly into the whole sheet pile. So you see here a driving cap which is adapted specifically for the king piles, and the energy will be transmitted to the whole king piles except the connectors. And then with a vibratory hammer, we always prefer to use double clamps if you have a double so a box pile, or if you have the infill sheet piles, also to use double clamps. We know that it works in some conditions also with single piles, but it takes probably a little bit more time, and you might damage the sheet piles, be it the king piles or the infill sheets. There is a specific driving sequence. Sorry, click twice. So we call it pilgrim step. So first of all, you install the king piles with this template, and then you install the infill sheets. And there's also what we call a pilgrim step, and you see it in the video, which means that you don't drive one pile after the other. There is a sequence that you have to follow in order to be sure that on both sides of the king pile that you're driving, you have either compacted soil or uncompacted soil. The template has to be relatively rigid. Normally it's a 2-level template. The height may vary between 3 and 5 meters. So here it's a 3.5 meter high for a specific project in Taiwan. As you can see, it's a rigid frame. It will depend also on the length of the pile, and then you have to guide it. This was the old system, the HZ. You see here how it was guided, but we prefer to have a solution with rolls. Not necessarily rubber rolls, but rubber rolls if you have a coating, of course, to prevent damaging the coating. And then this is a nice picture because here it's a different solution. It's in Germany, here the Weserport, where they fix the template to a barge, checkup barge, and then they drive the king piles. So it's not necessarily, don't necessarily need a template like you saw it, but you can also use other alternatives as long as you can guarantee the verticality of the piles. Another thing that we see a lot in Germany is what they call Sicherschnitt. So it's a way to cut the tip of the pile, as you see here, so that it penetrates better into very compact soils. It's something that can be done, and then reinforced with a plate here, the tip of the pile, so that if you have to drive into very compact soils, you have less probabilities to damage the tip of the pile. There is a short animation that you can find on our YouTube channel that we'll show it now, I guess. Okay, so you might have seen, it's a nice short video. I mean, you have seen that the advantage, as I probably mentioned right at the beginning, is that you can work from a checkup pouch, so you can install the sheet piles and being backfilling at the same time, so you don't need to pre-dredge or you don't need to backfill before you can start. So from this point of view, it's a relatively quick installation. The other thing that you saw is that normally, what I didn't mention is that normally you start driving or start installing the sheet piles, the king piles, with a vibratory hammer, and then when you get stuck, when you go to refusal, then you drive the last meters with an impact hammer if required. But for infill sheet piles, normally are always driven with a vibratory hammer. Now, sorry, click on the slide. So I mentioned that driving tolerances mentioned in EN 12063, but what I highlighted in red is that for the primary element of a combined wall system, be it the HZ or a tube, there is nothing prescribed. It depends on the soil conditions, on the length, and so on and so on. So you have to agree for each installation, for each project, what are the tolerances that are acceptable. It will depend on the length of the pile. As I said, for 44-meter long piles, it will be different than for 10-meter long piles, because the 200 millimeters is the maximum that you can achieve, generally speaking. But keep in mind that it should be anywhere between 1% in verticality and 0.5% for very long piles. This is the aim, but to be checked for every project. Now for the anchors, you saw also in the picture that there is a special device that was developed so that you don't need to weld it. That's the one that you see here with the zoom. So you have simply to push it through the slots that you can do below water, sometimes even, and then you have this hinge system with the pins, so relatively easy to install even underwater. However, in Germany, they like a lot different ones, so they use battered piles, and then they fix the battered piles to the top of the king piles with a specific system. Here, it's one way to do it. They have beams with plates and also these tubes that are fixed on the HZ, and then it's concreted, so it will be in the concrete capping beam, as you can see here. So it's a little bit more complex, but it works very well. And then another way to do or to optimize or in certain conditions. So for instance, this was in Gdansk. It's what we call flap anchors or Klapp anchor in German. Relatively good solution with the hinge here that you can see. And then you prepare the anchor wall. So the sheet piles anchors, they are fixed to the H-beam, which can be very long. And then you simply drive it into the soil. So if you have the soil here at minus 12, and that's the way, and then you backfill behind. So it's relatively simple. It doesn't work in all the conditions for sure, but sometimes when it works, it's a very competitive solution and quite innovative, as you can see here. So it has been done in Poland, has been done a couple of times also in Germany. And just to finish my presentation, a few pictures. So this is a picture of the new iron ore terminal from JSW in Paradip in India, where we supplied last year, so in 2019, about 2,500 tons of a combined wall system, HZ 1080MA, with 27 meters, so the king piles, and 21.5 for the infill sheets. There was also another system which was a little bit smaller, and with the anchor wall it was about 2,900 tons. Then this is the nice picture that we also saw in the animation, a double, so it's was built like a jetty and then backfilled behind. And as you can see, the advantage is that they are working from the portion that was already installed, and then they have the feeding of the infill sheets and so on a barge. Piles up to 33-meter long. That was the one in Germany, so the Weser port, where we supplied more than 44,000 tons, with length also up to 44 meters. But as you can see also here, they use these battered king piles, and a relieving platform to reduce the soil pressure, because they went down to -20, but the design was done at -23 meters. So from -23 up to +7. +7 is due to the flood wall elevation that they had to be above +7, so +7.5, and sheet piles up to 44 meters, and the anchor piles here up to 56 meters. Another project, the locks in Venice. Most of it, you don't see it anymore, but we supplied also around 150,000 tons, also for the gates that have been built, which will protect from next year on, hopefully, the Laguna. And then a last one, also in the seismic region. So you had the webinar on seismic previously, and the HSAT system is also very good, has also very good behavior in the seismic region. Sheet piles that were up to 28.8 meters long, small ones from the 575, that was for the anchor wall, up to the largest one that we had at that time. And just to finish, so you have all this information, the technical one, but also the data in the brochure, also with the water pressure, resistance, and so on. So have a look at it, and also at our website, where you can find some details, and also the software that you can download, as I mentioned. So thank you very much for your attention. And hopefully you had some questions.
Thank you, sir. Thank you for the wonderful presentation. So we thank ArcelorMittal for being a series sponsor in this steel webinar series. We thank Teamwork Engineering Solutions Private Limited for being a co-sponsor for the steel webinar series. Now we'll watch the promotional video of our sponsors, and then we'll proceed to the QA session. So I welcome Ms. Amruta Vijayan to coordinate for this QA session.
Yeah, thank you, DFI, and thanks, Jao, for that presentation. So we have a few interesting questions. So the first one, I think I can take it. It's from Mr. Balkumar Venkatraman from Simplex Infra. The question he is asking us, the sequence of installation plays a very important role. Can you please explain this? I think, Jao, we have covered this. In terms of how the staggered installation happens, and also Mr. Balkumar, we would strongly recommend that you attend ASLA's, DFI India's next webinar, which is on September 9th. Now, is there anything else that we have to add to this particular question?
But I think that if you watch the short movie, it explains the installation sequence. And we have also a specific presentation on installation of the combined wall system, but it would take way too much time. So we were here limited to 45 minutes. That's why I could only show the basics. But of course, the sequence is very important because, as I try to explain here, you have to make sure that you don't compact the soil on one of the parts, that you have the same soil conditions on both of the parts when you install the king piles, and also because they are longer than the infill sheet piles. We've seen people doing it differently. It might work. I'm not saying that the way or the procedure that we recommend is the only one that will work, but we know that if you do it according to our recommendations, you will succeed.
Right. And the next question, we had shown, this question is from Mr. Anil Kumar SV. We had shown a sketch or a cross-section of Port San Antonio in Chile. The question is specific to that. The question is, are cantilever sheet piles trimmed to existing dredge level by cutting underwater?
So the question was, can we?
Are the cantilever sheet piles trimmed to existing dredge level by cutting underwater?
This is something that can be done, but here it was not. I don't think that it was done because actually you ordered the piles to the length and then you drive it to the dredge level, and even if it's a few centimeters above the dredge level, the existing one, it's not a big deal. So in this particular case, in Port of San Antonio, but cutting below water is something that was done in another port. But cutting underwater is also quite expensive and it takes also a lot of time. It's like welding underwater. It's also possible, as the project that we showed in Denmark. So there was no welding underwater for the anchors because we try. Well, at least you should try to have a solution which is easy to install, but also taking into account the finishing and also all the steps.
Okay. So the next question is from Mr. Rajan Peter. So he asks, how many connectors are used for, say, a 10 meter of pile depth, or is it only at the top or bottom? So maybe what I understand from the question is, if the connectors can be staggered because it's a long element, can we stagger it for the length of the pile, or is it mandatory for it to have for the full infill sheet pile length? So that's what I understand.
Yes, so the connectors on the front part where you connect the AZ infill sheets, they have to have at least the length of the infill sheets. So if you have a sheet pile infill and AZ which is 15 meters, it should have at least 15 meters. Now, if you're talking about the connectors on the rear, on the back, where you have the solutions 14 and 26, there you can stagger the length of the connectors so that you match exactly the bending moment requirements. So it can be 5 meters, could be 10 meters, and if you have totally embedded, so if you have a maximum and a minimum bending moment, you could even have 2 connectors. So you would say, okay, let me cover the maximum and the minimum bending moment with the connectors if the sheet pile is very, very long. But usually they are also done only in one piece, also on the back. But on the front, definitely we recommend to have the length of the infill sheets at least.
Yeah. Okay, so there are a couple of questions from Mr. Bimal Chandra Roy. I think I'll combine it. So the first part of the question is, how will be the serviceability life if the permanent retaining structure is done by sheet pile, and do they need to be non-corrosive?
Can you repeat it? I'm sorry. So how?
How will be the serviceability life if the permanent retaining structure is done by sheet pile? Maybe we can compare it with any other serviceability life and then lifetime, and then give an answer.
Yeah, and well, for this one, it's the serviceability of a sheet pile structure or any steel structure will really depend on the atmosphere, on the environment. I mean, for waterfront structures, we have here in Europe, in the Netherlands, they have, and in Germany, they have built sheet pile walls that are 50, 80 years old, and they are still there. But you have to take into account the corrosion of steel, which changes also with the time. I mean, we have also seen that the corrosion rate might be limited after 20, 30 years, but at the beginning it's a little bit higher. So if you compare it to steel to concrete, for sure, steel, you'll see that it corrodes, and concrete you don't necessarily see, but if you have a reinforced concrete pile or reinforced concrete wall, you still have steel inside, and you have to make sure that you don't have corrosion of the rebars that are inside. And it's a matter of designing it. I mean, for the moment, what is mostly done in Europe and also in other countries is that you take into account the loss of steel thickness, and you calculate with a reduced bending moment capacity, with a reduced section properties, and then you design it for the service life. I mean, the key wall nowadays in Europe is designed for 35 years, maximum 50 years, and then you assume that you have to rebuild it or to do something different. And for a bridge abutment in the UK, normally it's 120 years. But in that case, you have only atmospheric corrosion or corrosion in the soil, but corrosion in the soil is relatively small. So in this case, the loss of thickness will be very reduced because of the environment. I think that where you have to really be careful is in the splash zone and also the low water zone for a marine environment, and there you can protect it either with cathodic protection if really needed, or with the concrete capping beam, where we will prevent this loss of steel. But for the serviceability, it's also, if you lose this thickness, the bending moment will reduce, but also the inertia, so you have a little bit more deflections. But that's something that you have to take into account into the design, and it's feasible. Which solution is the best will really depend on the specific projects.
Okay. So next one is it's a very interesting question, slightly long question from Nitya Kalyani from L&T. Are there any particular advantage to HZ piles compared to the tubular piles in combined sections? Since tubular sections offer more section modulus with a smaller depth. Also, why most of tubular sections proposed by ArcelorMittal are falling under class 4, particularly in combined wall brochure? Any particular reason?
If you look at, well, when I introduced the HZ system, one of the first combined wall systems that you had in the past were U piles, where you had box piles, and then infill sheet piles, which were U piles, and this was in Germany and in France. And then later they came with the Z piles, box piles, and in the 70s we introduced the HZ, and in Germany there was a manufacturer which had a similar system. And I think that at that time, tubes were not a common solution due to the fact that you didn't also have these connectors, that you wanted to weld those connectors to the infill sheet piles. And I think that was also the difference between the tube with the connector, which you have to weld. And welding, as you know, if you don't do it correctly, then you might have a big problems afterwards. And it has changed in the meantime. I mean, in the past, the HZ system was only a mechanical connection, so you did not even have to weld the connectors to the HZ, and you did not consider the infill sheet piles. And it evolved with in the 90s, where we introduced the AZ, but still with this mechanical connection. Now, the tubes are on paper more effective if you use a large diameter and a small thickness. But obviously, if you use a large diameter with a small thickness, you have a high ratio between the diameter and the thickness. So you go very easily to class 3 and even class 4. And that's one of the big issues. So now they did some testing, well, years ago, they did testing in the Netherlands to change this classification. And if you use the methodology that's also described in the design manual, you'll see that some of the steel tubes that were class 4 in the past now are class 3, if you use them for foundations, of course. But as I said, we also had to do this research for the HZ, for the classification, because you have also the connectors, and the connectors have an influence on the classification, a positive influence, in fact. So why now we would propose, or other people would propose, class 4 sections for tubes, it's not very clear to me. I mean, it's obvious that you want to use the lightest pile. So the lightest pile will be big diameter with small thickness, but you have to take that into account in the design. So, and that's where the experience, but also the calculations methods, and you'll find calculations methods in the United States that are not the same as we use now in Europe or we use in the Netherlands. So you have to make sure that it will not fail. But even the class 4 section is a good section. It's just that you cannot use the elastic section model. So you have to analyze the fact, is this solution, even if it's a class 4, more cost effective than a class 3 section where I have more material? So this is something that has to be analyzed on a project basis, I would say. But again, class 4 does not mean that you cannot use it. It means just that you cannot use the elastic section properties. So you have to find the correct, well, the most optimum solution based on the design.
Yeah. So the next question is more on installation, but I think that is quite interesting. It's from Govinath from Keller Ground Engineering. So his question is, how can we stabilize sheet piles? Maybe if it goes off axis, and inclination. Also, is it possible by a cable anchor? That's the question.
I believe that I know what is referring to. However, for the combined wall system, we have the preference, well, we prefer that if the installation tolerances are not within the prescribed values, then you have to extract the pile and redrive it. Because, or what is also possible is that you use an infill sheet pile, a special infill sheet pile that you fabricate so that it fits these installation tolerances. Pulling or pushing sheet piles, it's something that is done sometimes with regular sheet piles, but I would definitely not recommend it for combined wall system. And make sure that using this stiff, rigid template, you install the king piles correctly. And then once the king piles are installed in the correct position with the verticality and so on, then you can install the infill sheets without any problems.
Yeah. So there is a question from Biswajit Paul from HCC India. What are the differences between solution 24 and solution 26? And any particular conditions, specific conditions we can choose to use these solutions?
Yeah, so solution 24 is, as I tried to explain, but probably a little bit too quick. We have two king piles and 4 connectors. So 2 connectors to connect the HZ and 2 connectors to connect the infill sheet piles. The disadvantage of solution 24 compared to 26 is that it's a slightly unsymmetrical profile. So this means that if you look at the section properties, the neutral axis is not on the middle of the HZ. If you use a solution 26, in that case, you have almost perfectly symmetrical profile. However, the cost of the welding, but also the cost of the connector is slightly higher than the cost of the HZ, which means that if you try to optimize, and even if you try to optimize with the length of the connectors on the rear, so you can use those 2 RH connectors that are smaller on the back of the flange, what we have seen is that due to the cost of welding, and especially the cost of welding here in our countries, I mean, because it's relatively expensive compared to other countries, it means that the solution 24 will be, in most of the cases, cheaper than a solution 26, even though the profile is unsymmetrical because of the fact that you have to weld these connectors on the rear. And it takes also a little bit more time because you have to thread the connectors and you have to weld them. So, but the difference is relatively small, and it really depends also on the difference of the section models. So if you go to an 880 to a 1080, the conclusion might be different than if you go from an 1180 MA to an 1180 MB. So there's also some specific, how would I say, features, because you don't have a continuity in the elastic section and the plastic section modules. So what we do normally is we analyze both solutions, and then if we want to propose an alternative, we'll choose the one which is the most cost effective. But generally speaking, solution 24 would be more cost effective than a solution 26.
Right. So I think I have time for one last question. I'll take it from Steny. So what she says, the thickness of the tube, this is actually a continuation of what we discussed on tubular piles, being class 4, can we use it or not? It's, I think, a continuation of that. The thickness of tubular pile may be less for a given diameter for strength calculation, but one must remember that the thickness also determines the service life of the structure or pile from a corrosion perspective, clearly given equivalent anodic or cathodic protection. So whether we agree with this or not. Do you want me to repeat?
Thank you, Amrita, very much for
Yeah. I think
moderating
we've lost
this.
now in between. What I would like to say again is that all the questions, there are a lot more questions that I'm unable to take it, but through DFI, we will send a consolidated reply of all the questions that we have got, and we'll probably include some examples also, and any research work that is we can share. We'll certainly do that with all the people who have participated in this webinar. And thank you very much, DFI, and thank you, Lucky. And to the DFI team and all the people who have attended the session today.
Thank you, Amrita. That was great. And thank you, Shaus Martin, Mr. Shaus Martin. It was really great presentation, and I'm sure attendees got a lot from this presentation. Thank you. So I just wanted to bring up your attention to the next webinar, which is going to be on 9th September at the same time, 4 p.m. Indian Standard Time. The title will be State of the Art Sheet Pile Installation Techniques, and the speaker will be Mr. Ernst Weber. The information of this next webinar is also in the handouts. You can get that information, or you can reach out to any of the DFI staff for more information if you need. And there is another exciting information that I wanted to share is DFI India 2020 conference is coming up. It is November 19th through 20th. It is going to be a virtual conference. We all know most of the conferences this year are becoming more virtual and virtual. So we welcome all the attendees to register for DFI India virtual conference. The link is shown in here, and the link also is in the handouts. So we do have few things for virtual conference programs that we want to share. There are 3 pre-conference webinars that were planned. There is one that was completed on 20th August. There is one on 17th September, 22nd October, third one. So you can register for the 17th and 22nd. The virtual conference is on November 19th and November 20th. Don't miss to register for the conference. So the titles you can see for the pre-conference webinar number 2, and also for the pre-conference webinar number 3. And you will see the speakers are also 3 speakers for the webinar 2 and 2 speakers for the webinar 3. Again, this information is in the handouts and also on the DFI India website. The conference registration fee is shown in this slide. This again can be found in the handouts and also in the DFI website. And we are also asking for sponsors for the conference. Make sure to check out the opportunities that you have on the DFI website and also on the handouts. And the contacts will be TS Mahindran and also Mohammed Atif. You can see their phone numbers and their emails as well. It is open sponsorship opportunities. Reach out to your companies and see if you're interested in sponsoring for the conference. So now I would like to share a few seconds about Women in D Foundation's committee itself. So DFI India 2018 conference, Women in DFI group was launched. And in 2019 conference, we actually had a panel discussion, which was the topic was challenges for women in the industry. And Women in D Foundation's activities since then has been, we have started a WhatsApp group, and also we are planning a webinar series. Acing the interview is the theme of the webinar series. It will have 3 webinars following it. Consulting, academia, construction are the 3 different industry corners that we will be focusing on for the Acing the interview. If you would like to become a part of this group, please contact L. Nagarajan at geekinamerica.com or DFI India office. We'll be happy to have you as part of our group. It can be men and women both. We are not talking about only women to be in the group. And thank you very much for DFI for this webinar series and webinar number 3. Please return on 9th September at 4 p.m. the same time, IST for webinar number 4. Thank you so much.